Welcome back. Now, today we'll be talking about normal forest. A forest is said to be normal when it has a normal increment, it has normal distribution of age classes, and it has a normal growing stock, which is given by Schilling. The same thing has been put by Osmaston as it is the forest that has reached and maintains a practically attainable degree of perfection in all its parts for the full satisfaction of the purpose of management. Now, how we are going to understand this? We're going to understand the normal forest with the help of this diagram in case of clear felling system, where we maintain different age gradations from 1 to 10, each age class occupying an area of 1 hectare. And when it is planted in the first year, it keeps on growing and reaches to maturity in the 10th year, and the amount of increment that each age class puts in a single year is 50. You can see here. So when it reaches to the 10th year, it becomes 10i, means 10 into 50 is equal to 500. This is going to repeat in the next year because the 9th year plantation is going to move to 10th year plantation, 8th to 9th, 7th to 8th, and the sequence continues like this. So we are going to get yield from this forest or increment from this forest in perpetuity if we are going to plant just after harvesting the particular age class. Now the increment put on by different in a particular year by different age classes is equal to these sum of these I in the square, the dotted squares, I1 I, and that comes to equal to 10i. Now we have a problem of taking the harvest from the immature classes. We cannot take harvest from them. So but increment has been produced by each age class. We take all those 1 2 3 4 10 i's from this mature age class which is ready to be harvested. It has the volume of 10i, means 10 into 50, 500. So we are taking the yield or increment on behalf of all other age classes from the final mature class. So what are the three properties? Which is normal increment. It has a normal increment because we are going to get this 500 meter every year without endangering the future yield. Number two, it has normal distribution of age classes. As you can see, it has all the age classes, no age classes missing, age 1 2 3 4 5 up to 10. And number 3, it has a normal growing stock. It has a normal growing stock because the growing stock is giving you normal increment without any compromise, without losing its volume or without enhancing its volume. So this is how we understand normal growing stock. Now there are some kinds of abnormalities in a forest. A forest may be overstocked. Why? It may be overstocked due to forest has past the age of maturity and we have not felt that, so it's an abnormal forest. There is excessive distribution of older classes. You already know that the higher age classes puts on higher volume than the lower in age classes. So there may be excessive distribution of older age classes which is giving an abnormality to the forest, or we have extended the rotation that is already prescribed to it. Now how we are going to overcome this overstockedness? This condition may be corrected by reducing the rotation. We have to reduce the rotation. Now there's another abnormality in forest, which is the forest may be understocked. How? The forest is understocked because of the preponderance of younger age classes. Earlier we had excessive distribution of older age classes in overstocked, but here in understocked we may have larger number of younger age classes, which is not putting so much of the volume as is required. It has a poor density. The forest may be understocked due to this, and if we reduce the rotation, the forest may be understocked again. Now how we can correct this? We can correct this by adopting a rotation longer than necessary. So we have to wait for another few years. We have to increase the rotation so as to decrease or remove this abnormality, so as to get a sustained yield from the forest or make it normal. Now the third thing is, the growing stock is normal, but the distribution of age classes or age gradations is not normal. Now this has to be has been seen as the worst abnormality. Why? Because the conversion is very difficult in this, to have a regular series of age gradations, and the conversion involves interruption. You have to interrupt. Suppose some age class is missing, or you have to interrupt, or you have to extend your the harvesting, so as to get the desired age gradations and age classes. uh, but that is possible only when we have to the sacrifice of the material has to be done to achieve this goal. Now there can be normal increment volume in an abnormal forest. Now the forest may be as such abnormal, but it's somehow giving you the normal increment. It is again not correct unless the increment has to be laid on the right age classes. Each age class must have a contribution, a proportional contribution in giving the increment, so as to make the forest normal. So this is the profile of an abnormal forest. You can see the increment put on by this was the normal. This would have been the normal forest, and you can see the abnormal forest. The volume sometimes is quite high, and the volume sometimes is quite low. It's not distributed uniformly over the desired age classes as